This is Algebra 2 practice writing formulas for arithmetic and geometric sequences. Okay, so there are two kinds of sequences that we've been talking about. The first one is the arithmetic sequence, and the second one is the geometric sequence. All right, an arithmetic sequence is a sequence that increases by addition or subtraction, and a geometric sequence is by multiplication. So you have to decide whether a sequence is arithmetic or geometric and be able to write both an explicit and a recursive formula for that. All right, so we're going to look at both of those. So let's look at the first one we have here. The terms of a sequence are 1, 3, 5, 7, 9. All right, would this be an arithmetic sequence or a geometric sequence? All right, that's determined by how you are increasing as you go from here to here. What's happening on every term of the sequence on this? We are adding 2. So if we are adding each time 2, that makes this arithmetic. All right, so this is the common difference is going to be 2. All right, this is called the common difference. Okay, so we have two kinds of formulas that you could write for a sequence. You can either write the explicit formula or the recursive formula. All right, the difference between them is an explicit formula is a formula where you just plug in the term number and you get the term. So say you wanted to plug in the 20th term of the sequence, you'd plug in a 20 into the formula and you'd get the term number. All right, the recursive formula is where you have to use the previous term. Okay, so you have to know all the previous terms in order to do that, and you have to know where to start it. All right, let's do the recursive formula first for this, okay, because that's usually easier. Okay, now, with the recursive formula, there are two parts. The first part is the first term. You always have to tell where the sequence starts. What is the first term of this sequence? Well, it would be 1, so A1 is equal to 1. All right, then this part of it is the rule that tells you how to find each term of the sequence using the previous term. Okay, so if A of n is your term, the previous term to that would be A of n minus 1. Then what do you do every time on this particular sequence? Well, we were adding 2. So that is the recursive formula. Now, you could use this to find any term of the sequence, but it would take a lot longer. So you have to be really careful to make sure that you know the previous terms in order to do that. If you are looking for a specific term, you probably want to use the explicit formula. Okay, the explicit formula, general form, is A of n equals A1 plus n minus 1 times d. Okay, so first of all, you take the first term and you add something a certain number of times. The something you add is the d. And the number of times you add it is always going to be 1 less than what you started with, or what term you're on, I should say. Okay, so for this particular formula, A of n equals, all right, what is the first term of the sequence? Well, it's going to be 1. All right, now, I don't know how many times I'm going to add, so I'm just going to say n minus 1, and what's my common difference? My common difference is going to be 2. Okay, now you can leave it like this, but you can also solve it for distribute and solve and combine your terms so it looks more like a linear function. So that's what we're going to do. All right, so we're going to distribute the 2 through here, 1 plus 2n minus 2, and then combine your terms. So A of n will equal 2n minus 1 when you combine your terms. So if I plug in 1 here, 2 times 1 is 2 minus 1 is 1. It gives me the first term. If I plug in 1, 2, 3, 4, 5, 2 times 5 is 10, minus 1 is 9. I get 9 as my answer. So for this form, all right, this is called an explicit formula because you can plug in the term number and immediately know what the term is. For recursive formula, you have to know the previous terms to do that. Okay, now you can leave it like this. Most of the time it's done like this as well. All right, so this is actually an acceptable form that you may see as well because it follows this formula right here. Okay, let's look at the second problem here. The terms of the sequence are 2, 4, 8, 16, 32. All right, so first of all, is this arithmetic or is this geometric? All right, well, what's happening every time as we go up here? We are multiplying by 2. Okay, so if we are multiplying by 2, that makes this geometric because we are multiplying to get every term. Okay, so for that, remember this is called the common ratio. Okay, so if that's the common ratio, we have to know what that is what we're multiplying by. All right, so for the geometric sequence, in terms of the sequencer here, let's do the recursive formula first. The first term is 2. So A1 is equal to 2, because you always have to tell me where the first term is. And then the recursive formula, you have to use a previous term. So if A of n is our rule, the previous term to whatever term we're on, n, would be A of n minus 1. And then what are you doing every time? You are multiplying by 2. All right, so that is your rule. That's your recursive rule. Okay, now for your explicit formula, you need to know the general formula for a geometric sequence. The general form for a geometric sequence is A of n equals A of 1 times the common ratio multiplied n minus 1 times. So that is that, because it's always one less than whatever term number you're on, because we're starting at the first term. So if I use the explicit formula for this one, what's my first term? Is going to be 2. Okay, what's my common ratio? Is also going to be 2 to the n minus 1. Okay, now this is kind of awkward, 2 times 2 to the n minus 1. If you remember, this is really 2 to the 1 times 2 to the n minus 1. So if I combine my, multiply my bases, they're both 2, what do I do with the exponents? I'm going to add them. So this is actually going to be A of n is equal to 2. Well, 1 plus n minus 1 is just going to be 2 to the n. So if I plug in, say, 1, 2, 3, 4 here, 2 to the 4th gives me 16. All right, I could plug in any number n, and I could tell you exactly what that term was. If I wanted to plug in the 20th term, I'd plug in 20 here. If this would be 2 to the 20th, would give me that formula. So again, this technically is an acceptable formula. This is just combining the terms when you do that. Okay, let's try the next one. We have the terms of a sequence are -2, 1, 4, 7, and 10. Okay, first of all, we have to determine if this is arithmetic or geometric. What's happening every time as we go from term to term? Are we adding or we're multiplying? We're actually multiplying. We're adding 3 every time, and it has to work for every term of the sequence. So if we're adding 3, that makes it arithmetic. Arithmetic, I can't spell. So that means the common difference, or the D, is going to be 3. Okay? So let's do the recursive formula first. All right, we always have to describe where we're starting the sequence. We're starting A1 is going to be at -2. Don't forget this part. People forget that all the time. All right, then the recursive formula, A of n, is equal to the previous term. If we're doing recursive, you have to have previous term. It's going to be A of n minus 1. And then what are you doing every time? We're adding 3 because that is the common difference. Okay, now let's do the explicit formula. Remember, following the formula, A of n equals A1 plus n minus 1 times D. That's what's on the Regents reference sheet actually too, so it is there. All right, so A of n equals A1. A1 in this case is -2 plus n minus 1, and then D in this case is going to be 3. All right, now let's combine our terms when we do this. We're going to distribute -2 plus 3n minus 3, and when you combine your terms, you get A of n equals 3n minus 5. So if you plug in your terms here, plug in the first term, 1, you should get -2. You plug in 2, you should get 1. Plug in 4, or excuse me, third term, you should get 4. Plug in fourth term, you should get 7. Okay, so when you plug in the term number, you should get the numbers in this sequence. Okay, for number 4, the terms of a sequence are 1, 10, 100, 1,000, 10,000. All right, are we adding or are we multiplying when we do this one? We're actually multiplying by 10. Okay, so every time that we go up here, we're multiplying by 10. That means that this makes this geometric. Okay, so let's do the recursive formula first. The common difference, or the common ratio, is actually going to be 10 for this one because we're multiplying by 10. All right, recursive formula again. You start at the first term. A1 is going to be 1 for this one. A of n means the previous term, which would be A of n minus 1, and then you would multiply by 10. All right, that's the recursive formula. Take the previous term, multiply by 10. All right, the explicit formula, you have to be careful about this. All right, so the formula is, again, a of n equals the first term times the common ratio multiplied n minus 1 times. Okay, so the explicit formula for this one is going to be 1. My common ratio is going to be 10 to the n minus 1. And you can simplify that if you want to, just to be 10, because 1 times 10 is just 10. You can this just be 10 to the n minus 1. Would work quite well for that. Okay, so that is the explicit formula, and that is the recursive formula for this. Now that should give you some practice on the difference between writing an arithmetic sequence or a geometric sequence, and how to write both the explicit and the recursive formulas for them.